Good morning, everyone, and welcome to today's webinar. My name is Jens Helberg, and I'm the CEO of TruckScience. We're hosting this webinar in conjunction with NTEA, and I extend a special welcome to all members joining us this morning. Our partnership with NTEA gives members access to our Axle Weight Calculator software at a reduced rate. Optimizing payload is a crucial step in any commercial vehicle operation, whether it's in the design, manufacturing, or operational domain. This webinar will cover some of the principles and techniques involved in this process and aim to answer your questions about why, when, and how to apply them. So let's get started. Today, we'll be using 3 real-life examples to illustrate ways to optimize payload. First up will be a Ford F350 with a service body and center axle drawbar trailer carrying machinery and equipment. Next, we'll use a Kenworth T370 with refrigerated van body carrying palletized freight in a multi-drop operation. And lastly, we'll again use the Kenworth T370 but this time with a tanker body carrying diesel and gasoline. Let's dive deeper into these scenarios using the Axle Weight Calculator app. So first of all, we're designing the service truck for operation in California. So I'll set up the regulation to validate against that. It's set to the US Federal Common Size and Weight regulations by default, but I'll select the Californian regulations. I'll also select a few attributes of the vehicle and of the build that we might be interested in, and I'll choose the gross weight on the vehicle's front axle as a percentage, and I'll also add the tongue weight as a percentage as we're adding a trailer, and lastly I'll add the frontal area of the vehicle. I'll also include a couple of internal standards. These are internal limits that we want to adhere to due to legislation or just safety standards that we want to enforce. So I'll select that the gross weight on the vehicle front axle, and I'll specify a range of between 20 and 100%. And I'll also add the tongue weight, and I'll specify a range of between 10 and 20%. So now that that's done, I'll start off by selecting the vehicle, and I'm going to be using a Ford F350 4x2. So I'll go into the OEM database here and select the vehicle that I'm after. And you'll note that the front and rear axle weights have been specified by default. This is have been pre-populated rather. These are the weights of the default spec. And I'll then go ahead and select a service body, and I'll use the napide designed specifically for this vehicle. And I'll just drag that across to center it across the rear axle, like so. If I want to do custom design a body, I could have used one of our templates, and these give you free rein on weights and dimensions. Another alternative is to import your own DXF drawing of one of the bodies in your own range. So I'll also add a lift-more crane. And I'll just position that to the rear of the body around about there. And that completes my build. Now let's say, for argument's sake, that we have a diesel engine that needs to be collected from a building site and brought back to the workshop for repairs. So I'll load that up as payload. I'll just search in our list of components. And I'll put that diesel engine, and straight away we notice that there's an overload on the front axle. And looking at the weights table, I can see there's a bit of unused capacity there on the rear, about 2,500 pounds. So I'll just drag that engine up to a more realistic level, and then I'll just pull it across, and note how as the load center moves towards the rear axle and takes advantage of that excess capacity, the vehicle becomes legal again. So now let's add a trailer to the combination. I'll just need to add a hitch first. And I'll put that on like so, and then I'll select a center axle drawbar trailer, and I'll select one that I've saved to my personal library beforehand, just for the purposes of this webinar, just to save a bit of time clicking it together. But this trailer was constructed using our templates. So I'll add that in there, and note that by adding the trailer now, these internal standards have been flagged, and I'll just drill down into that and see that it's the tongue weight as a percentage of trailer weight that's been flagged. And if I look at the value that's been pinned to the dashboard, that's at 5%. So that's probably to be expected since we don't have any payload on the trailer yet. So I'll leave that for now and go ahead and add the bobcat, or add a bobcat, and see what happens. So note that the vehicle is now overloaded due to the additional load transferred via the hitch, and our tongue weight as a percentage has also been flagged. If you recall that tongue weight, we had specified a range of between 10 and 20%, and we can see that's now at 26.2%. So this percentage is a crucial factor in the stability of the vehicle, and it ensures that the driven axles have sufficient traction. It's important to comply with the hitch manufacturer's recommendation when specing a combination like this. So by default, the bobcat has been placed at the very front of the trailer, but we can experiment with its positioning and see what effect that has. So if I just drag that back ever so slightly, just 2 inches, the vehicle then becomes legal. But we note that the tongue weight as a percentage is still at 25%, which is outside of the range that we'd specified. So I'll drag that a bit further back until that falls within range. And that's now at 16.1%. And we've decided we're okay with that range. So now that we've spec'd our vehicle, I'll generate a PDF for the customer, and I'll add some additional notes here, just specifically around the bobcat. And I'll say, please load the bobcat as per the load plan. And I'll just apply that, and it generates a nice PDF document with all the weights, dimensions, and along with the notes that we've specified. So Martin, before we move on to the next example, are there any questions at this stage?
Yes, Jens, there's one question about the DXF import feature for trailers. So I suppose it is relevant because we've just dealt with the trailer there. So yes. When will the DXF import feature be available for trailers? Because remember, right now we can cater for bodies, equipment, and payload items on that feature, but that feature is not yet available for trailers.
So that's an excellent question. We prioritize these features based on customer feedback, and as like the more requests we have for a particular feature, that kind of pushes the feature up in terms of priority. So we haven't got that scheduled in for the next sprint, but certainly just hearing it now on this webinar, we'll add that person's voice to the list of people looking for that feature.
Yeah. Okay, Jens, I suppose there's another question here about access to the software for NTEA members. And I think the question may be, do NTEA members get free access to the software? And I suppose you will explain that in a little bit more detail later on, or do you want to just mention anything there?
Well, I can certainly say it now already. So this isn't free software. However, we have the terms of our partnership with NTA allows members to get access at a discounted rate of, or they receive a 10% discount on the subscription. And I'll go into the pricing information a bit later in the webinar, if that's okay.
Yeah. Okay, so that's all for now. So please feel free to post more questions and I'll try and answer them, or I'll pass them on to Jens at an appropriate time.
Right. Thanks for those. We really do encourage questions to make the session a bit more interactive. So please continue to submit more. So for our next example, we'll design a refrigerated truck to transport palletized freight in the New York tri-state area. So I'll go ahead and set up those regulations. I'll clear the existing ones and I'll select New York, New Jersey, and Connecticut. I'll remove some of the attributes we'd tagged before, like frontal area and tongue weight, since we won't be including a trailer anymore, and I'll just add the static rollover angle, just out of interest, and remove the tongue weight as an internal standard range. I'll retain the gross weight on vehicle front because that's quite an important one to keep a note of for most builds. So we'll use a Kenworth T370. I'll take the 6x4 and I'll go ahead and add a box body. By default, it's added it with a width of 96 inches, but I'd like to maximize the floor space for our pallets. So I'll just go ahead and increase that to 102, and that'll be our maximum. And I'll go ahead and add a refrigeration unit, and I'll take the Thermo King T600. And as I add the refrigeration unit, I can see that it's interfering with the cab. So I'll need to adjust the height of the body, and I can do that by clicking on the dimension there, and I'll just push it up a bit. And as it goes up, you'll note that it flags as it goes past the 13.5 foot max legal limit, it flags the fact that there's an issue. And if I drill down to the regulatory compliance, I can see that it's an issue in all 3 states. So I'll just reduce that to a more comfortable level. And to complete our configuration, I'll add a lift gate. I'll take the Anteo CL22, like so. Right, so now that we have the vehicle configured, let's add the payload. So this vehicle will be used for palletized freight. So I'll select the standard GMA pallet. I'll just switch to top view so I can place them exactly how I want them. I'll place them so that there's a clearance between the pallets to allow airflow. So I'll go ahead and do that. And GMA pallet. And I'll just tweak the weight to 1,850 pounds. And I'll go ahead and make a copy of that for the second row, and I'll drag that up there and just place it right up against the headboard, and note that gap in between that I was referring to earlier. And I'll then copy the rest of them across. And I'll copy the second row across. Now you'll notice as we add that last pallet, it pushes the rear axle over the legal limit. And if I drill down into the regulatory compliance area, I can see that it's exceeded the limit in New Jersey and New York, but not in Connecticut, which is kind of interesting. So what we'll need to do is we have a couple of options. One option is to offload a pallet or two off the back before we cross the state line. An alternative is to just extend the wheelbase slightly, just to shift the load center more onto the front axle, because as we can see here from the weights table, there's about 2,000 pounds worth of unused capacity. So I'll go ahead and do that, and I'll just click that up there, extend it by 2 inches, and that solves the problem. A few other things to take a note of, I suppose, are the centers of gravity. I mentioned earlier that I was going to add the static rollover angle of the vehicle to the dashboard, and I can see that that's at 28 degrees. Now the static rollover is the angle at which the vehicle will fall over if tilted sideways and assuming a stiff suspension. So 28 degrees is a fair angle. So I would say this is sufficient. I can also just point out here the various centers of gravity that might be of interest: the payload center of gravity, the body center of gravity, and then obviously the overall center of gravity, and its measurement from the ground, which is 67.1 inches. So if we're okay with all of this, I'll just switch back to the top view and go ahead and generate my load plan for the driver, which will give them a nice overview of where to load the pallets or where to place them for their multi-drop route. Right. So before we move on to the last example, are there any questions that have come up in the meantime?
Yes, Jens. There's an interesting one here about the sort of detailed payload items there. And that's for an option to have multiple load plans for one vehicle configuration. So currently, the solution is to create your load plan and then save the calculation, do another load plan and save as to create a separate calculation. But then the problem is, what happens if there's a change to the chassis? Then that change needs to be applied to multiple calculations. So the users would like a feature where they could save multiple load plans per vehicle.
Okay, that's an interesting one. That's not something we've heard before. So yeah, certainly very interesting, and something we'll make a note of there for future functionality. Great, yeah. That's great feedback.
Yeah. Okay.
Okay, then. Our last example is designing a tanker to serve the greater Chicago area. So I'll go ahead and clear those regulations and specify Illinois and add some extra favorite dimensions. I'll leave the static rollover, but I'll include the vertical center of gravity of the vehicle, which might be of interest, and I'll also add that as an internal standard. So it'll tell me if I exceed that. So I'll just specify that as 70 inches from the ground, and this might be because I've seen that on an OEM spec sheet, or it might be an internal standard, whatever the case may be. I'll now be alerted if I exceed that. So I'll take that same Kenworth, but since we're building a tanker body onto it, I'll reduce the wheelbase, and I'll set that at 230, and I'll also reduce the afterframe. So we need to double check the impacts of the chassis reduction on the weights. you might check that with the dealer. I'll assume it's about a reduction of 100 pounds on each axle, so I'll just set that to 8100, and I'll set the rear axle to 6600. Now let's add a tanker body. I'll use a template, and I'll drag it 5 inches behind the cab, like so. And I'll also add a pump and metering equipment, and I'll do that by using a template. The template, if I had a DXF drawing of this bit of equipment, I could have used that and to make the drawing a bit more realistic. But using the template will still give you perfectly accurate results as long as the data you enter is correct. So I'll just rename that, and I'll call it pump and metering, and I'll tweak the dimensions. I'll make it 30 high, 30 wide, and I'll set the weight 2000 pounds, and I'll just position it like so, and I'll just drag it down and mount it on the chassis around about there. So now that we've configured the vehicle, let's take a look at the maximum achievable payload that the app has calculated for us. It's calculated at 27,500 pounds. Now this is assuming a single compartment in the tanker, and it's a water level load. Or I'll, just out of interest, I'll tweak the center of gravity. So the center of gravity currently of the payload is at 50%, and you'll notice as I move forward, you'll see here on the weights table that there's not much unused capacity on the front axle, and we're fully utilizing the rear axle. So if I move that load center forward towards the front axle, you'll see the payload starts dropping to, now it's at 18,000. So I'll just move that back to the middle, and we max out then at 27.5. But let's make this example a bit more realistic and add a few compartments to our tanker. First we'll add a diesel compartment. And I'll just tweak those dimensions, and I'll call it tank number 1. It's diesel, and I'll say the length is 72 inches, 60 high, 96 wide, and I'll have a look at the weight, and I'll just specify that as volume, because that's a bit less, that's a bit more convenient when you're talking about liquids. And I'll say I want to put 1,300 gallons into that tank. And now we have to specify the density to figure out the weight, and I'll just round that up roughly to 7 pounds per gallon for diesel, just for the purposes of the webinar. And I'll then copy these tanks. I'll create 2 more tanks, and I'll drill down to the second one here, and I'll call that tank number 2, and I'll say we'll put gasoline into that. And now note the weight is 9,100 pounds for diesel, and I'll say, well, because gasoline is less dense, I'll reduce that to a rounded down number of 6 pounds per gallon, which means I can then up the volume. I made that 14,000 gallons. That's a bit too much now, so I'll just make that 1,400. And for the last tank, I'll keep that as diesel, and I'll just say that's tank number 3. Now, if you remember, the maximum payload, assuming a single compartment, was 27,500. We've achieved 26.5. That's not too bad. Probably with a little bit more tweaking, we could get closer to the 27.5. But I think, but I'm quite happy with that for now. Something to just draw your attention to, and this is relevant to the previous scenario also, where we do a multi-drop scenario. It's the diminishing load as you offload the vehicle. one just has to make sure that it stays compliant in these interim stages. And I'll just I'll empty the last tank by zeroing the number of gallons in it, and you'll see that it now overloads the front axle because the load center has shifted to the front. So that's just something to take into account also when you're designing for multi-drop scenarios. So I'll just fill this tank again. And one final check then, nothing's been flagged in our internal standards because our vertical center of gravity is at 63.2 inches and we'd specified the max to be 70. So we're all good. The gross weight on the vehicle's front axle also in an acceptable range. So we can go ahead and generate the PDF for the customer or for the driver or whatever the case may be. And that'll give us a nice load plan to tell us how many gallons to put into which tank. And yeah, that'll give us a nice efficient build. So that's it for the examples. Martin, are there any more questions?
Yes, there are actually quite a few here, and maybe I'll just go through them here. There are two people who have asked about front and rear departure angles, and also the breakover angles, whether we calculate those and whether they take changes in axle positions or I suppose wheelbase into consideration. Right now, we do not do those calculations, but again, it is something we can note for future functionality. And I would say, yes, if you change the wheelbase or the rear overhang, the afterframe, then those calculations would be redone for that purpose. And also for the departure angle, you would definitely need to consider the bumper. If there's a rear underrun bumper, that would need to be taken into account as well. So definitely something for us to document for now. Then there's another question about the center of gravity. Do we have the option of showing both or two overall center of gravities? That would be one for the vehicle in the unladen state and one for the vehicle fully laden. I suppose it's easy enough to just zero the payload to get the overall center of gravity and then to re-add the payload. Maybe you can just demonstrate that, Jens.
Yeah, I suppose that the only way we can do that now is by zeroing the payload. So in this scenario, if we just take a note of this, the overall payload or the overall center of gravity at 63.2, and I'll drill down in there, and then if we empty the tanks, that gets adjusted to the new overall center of gravity.
So there's a bit of a workaround, but I can see the benefit of showing both the CG symbols. We do typically try to avoid sort of clutter on the screen, so it's just all about displaying the information in such a way that it doesn't overwhelm maybe users who just want a simplified view. And we could maybe offer an option to have a detailed or more detailed view of these dimensions. Then one last point here, or question as well. It's just a comment that the pump, that you've located the pump where the fuel tank would typically be positioned. So I suppose you could move the pump back slightly on the chassis. And that's, again, something that you normally need to check with the chassis manufacturer or your dealer in terms of the layout of the fuel tank position, the battery box, the def tank, the exhaust, and figure out exactly where you have available chassis space to fit any additional equipment. So that's a good point. And then in addition to that is, have you included the truck fuel weights in this calculation? And maybe you can just point that out, Jens.
Yeah, I suppose just the first question there, that's a good point, and we could experiment with that a bit by moving that and making sure that our build remains legal. I'll just move that, say, to around about there. And yes, it is still legal. So or I can move it further back, probably still. Just on the fuel tanks, if you drill down onto the vehicle detail, you can do that either by accessing the menu or just by clicking on the vehicle, and you see the factory fitted fuel tanks section there. This spec has 56 gallons, has a 56 gallon capacity, and the volume that's included in the chassis weight is 0. So in this case, it hasn't been included in the chassis weight. It's been included in extras, and you'll find that under fuel and crew on the weights table there. And you can also drill down into that in a bit more detail by going to the fuel and crew view, which will spell that out for you. The crew then is 200 pounds and the fuel 383 pounds. So I hope that answers that question.
Yeah. And the last question here is, do you have the option to add a dump hoist and a custom sub body? So hoist on a platform body. So what we do cater for, and I don't know if you want to show it there, Jens, is to add a dump body and then to add the hoist as an additional item of equipment. Maybe you could just show that, to add an additional item of equipment, and you can give it any description and any weight and dimensions, but it would typically just be a rectangular box for the hoist. And
okay, so I'm going I'm going slightly off script here, so you have to bear with me. And we can then add a hoist, and as Martin says, we can use the template, or we could import that as a DXF file and get that in a more kind of realistic, get a more realistic depiction of it. So I'll just add it as a template because I don't have a DXF file handy, and I can then tweak its dimensions and its position. So I can rename that as a hoist, and I guess I don't know if maybe someone can help me out there. Would it be maybe 10 inches or
about 10 inches, and that looks about right.
Yeah, and something around there.
Yeah.
And that can then, and in that scenario, we wouldn't need the pump and metering equipment. So I'll remove that, and you can see its effect on the weight distribution calculation.
So you can add those components, the sort of sub body or the platform, the body and the hoist as individual items, or if you wanted to group any of those together, you could use that DXF import feature to combine the sort of sub body and the hoist if you wanted to, and then add the body as a separate item.
Yeah. I suppose another thing to point out is that if you have this hoist as a standard component, you can choose to save that either to your personal library to use it at a later stage, or share it with your team library, which would then allow everyone else in your organization to pull on your library of components, of standard components. The other thing to point out maybe is this pinning feature, which has recently been added. This specifies if once you pin a particular piece of equipment, so I'll pin that hoist, and you'll notice now that that component has been highlighted, and we can see its specific dimensions or relevant dimensions highlighted on the drawing. This is something that a lot of customers have requested, and we've just released that.
Yeah. Okay, Jens, I think that's it for now.
Okay, I'll just go back to my slide deck. So to sum up then, here are a few of the topics to consider when optimizing payload. One of the most important ones is the jurisdiction that you'll be operating in. As we've seen, that can have consequences if you spec it incorrectly. The choice of the chassis is obviously fundamental, and any modifications you make to the chassis, be that wheelbase, after frame, or adding axles, they're also very important. Then adapting your body design to the payload that you're carrying is crucial. So experimenting with materials, weights, and dimensions. And then adding a trailer can increase payload significantly, as we saw, if that suits your operation. And finally, testing the various components in different positions to come up with optimal placement. So now, getting back to the question that was asked earlier, if you'd like to try the axle weight calculator yourself, you can visit TruckScience.com and register for a fully functional 7-day free trial. There's a big green button at the top right that says Start Free Trial. And subscriptions start from $37.50 per month with no lock-in. So you can cancel at any time. NTA members qualify for an extended 30-day free trial and a 10% discount. So if there aren't any more questions, and I'm guessing there mightn't have, or there's one more come up there.
I think there's one more that we can quickly have a look at. It relates to loading the manufacturer chassis to our library. So the manufacturers obviously offer the vehicles in certain wheelbase options. And the question is, do we load the manufacturer's data and then modify the wheelbase according to maybe the available wheelbase options from the manufacturers? Or do we have total flexibility to change the wheelbase? So I suppose, Jens, maybe you want to answer that.
So there is what we do is load the standard wheelbase options as different vehicles, and then within that vehicle you have flexibility to change the wheelbase. So you aren't restricted to specific wheelbases. So that's obviously something that you'd need to clarify with the dealer, that the wheelbase that you're going for is approved and satisfies their requirements.
Yeah. So you wouldn't need to double check that wheelbase option is available. Jens, maybe if you just draw down onto those Fords and just show the list of all the vehicles, and you can see the field or the column for the wheelbase, and it's where we actually indicate the wheelbase options. So there, yeah. So those are the wheelbases according to the manufacturer, but we do allow you to still change those wheelbases. And perhaps that is something again that we should document, or in certain cases maybe lock down the wheelbase if a manufacturer does not allow any wheelbases other than the ones that they have specified. Okay, I think, yeah, so that was in the last question.
Okay, so that's great. Well, thanks for everyone. Thanks to everyone for joining us. I'll end the webinar shortly, but before you go, please rate the webinar and leave any comments or questions you'd like to share with us. If you would like to set up a personalized demo of the app, just leave your contact details in the comments and we'll gladly set that up. Thanks for joining us today, and we look forward to your feedback. Goodbye.